filming trash. You can watch me put cranks in cases or in boxes. Okay, I went ahead and B-blast the case here a little bit so I can try to see if there's a crack. So right now we're seeing nothing here. Now the crack is masked by the blasting slightly, but it looks like you said when you found over there. It also highlights when the oil comes through the crack, it's like a day glow. You can see it instantly where the crack is at.
Yeah.
So obviously there's a crack right there. But see, obviously it doesn't go all the way to the top either. So there's that crack. But it doesn't go at the top. It's right there. And then it kind of fades away, see? I don't see it down through here. It's only right there, which is kind of weird. Why would it break right there? The only thing that puts a load like that is a bending load. Trying to bend the case like this, which is, how the hell's the case going to bend like that? There's no load on it like that.
Yeah.
Kind of a weird place to crack. And you got this oil gallery is obviously right there, and I'm sure it's cracked in the oil gallery. It's a weak spot. But I don't know how it would have broken there. Why would it break there? But like I said, Harley cases break there too, so I don't know why. That's a common place to break on the 91 and 2 and 3 cases. They just crack all the way down about to here. Right on it, right there. And I don't know why they do it there. They do. They also break the whole top corner out. This corner is real common. The back corner over here is real common to come out. And then this one here a little bit, and then the other side over here. You rarely see the front ones ever break on the case, but this was real common to be through here cracked. They just broke like that. If you look at the 92 fxrp, one of the first ones I did, it's a Maxwell bike. We cleaned all the cases up, cleaned everything all up real nice. They looked really nice. There was no damage on the cases. We threw it up on the counter up in the front, by my front door. And I walked by the walkway, and I go, whoa, what was that? I was in the machine shop area, and it was 10 feet away. I walked by and I saw something like this where it kind of highlighted because it sat after I blasted it. I come back and look, it was cracked from here all the way up to here. So we went and bought a new set of cases because they had new replacement cases back then. But
Yeah.
his was a 92, I'm pretty sure is what yours was. But yeah, the case looked perfect. You didn't even see the crack. Like yours, you could barely see it.
Yeah.
And then, but once it got highlighted like this, it just opens it up. You can see it. But I don't know why it cracks there. Obviously, there's some kind of a load on something. All right, so we know this is broken. It can be fixed. You know, if you want to save the cases, you can. You know, if you want to save your numbers matching case. Well, your number's on the other side on this one. Yeah. So if you want the numbers matching motor, you can save it. Now this is the right side case. You can always get another right side to match it to your left. So that's an option for this. You know, you might look out and find one that fits halfway decent. Because to fix this here, you got to V this whole thing out. Obviously, this one here has to be cut out too, so you're going to cut this whole thing out too. So you're going to V out this all the way down. Don't cut the, don't V it out on this side here.
Yeah.
Cut this one all the way down through here, and probably cut this hole out too. Just cut this whole corner out right through here, all the way down into here. And the problem is, how do you V this out? I don't really want to cut this surface out. So that means I got to go back on this side somehow to do it. I'm not sure. You have to follow the crack.
Yeah.
You're going to wind up having to V into this too, probably. Somewhere you got to V into it, but I don't know where the crack's going. You got to see where the crack goes. You have to follow the crack and cut it out. Then you got to come back and weld that whole thing all up, and then weld this whole thing up. Now, what's going to happen is when you weld all that up, this whole surface here is going to go like that. Bad.
Yeah.
And you got to come back and weld in here and over here, and to get the metal back. You know, because you're not welding anything on this side; it's all welding on this side.
Yeah.
Now, if you come back and put a big bead over on this side here, all through here, and kind of pull it back a little bit, it'll pull back on you a little bit. But you have to put weld through here.
Yeah.
So you might V it out on this side a little bit on this side here, halfway on the bottom down here, and then V out the top on this side over here. Kind of do something like that, so you weld it from both sides, because you want to, one weld will pull back the other weld. But if all the welding is only on one side, it's just going to pull way hard that way. It'll pull over 30, 40 thou.
Wow. Okay.
So this one here, you might do V it on both sides. You know, maybe we'll leave this here, V it out deep through here. The problem is you got to put these holes back in after you're done.
Yeah.
And then come on this other side and V it on this side. And V it out over here a little bit, and then weld this here and weld it here, and that might keep it halfway straight. But the problem is the crack might just want to keep going too. You might start chasing it. So It wouldn't be as bad as this one because you start chasing cracks in circles. This side's real bad about that. This one's not as bad, but you know, it's not really that thick here. It's cross section wise, it's pretty thin.
Yeah.
Through all this area.
Oh yeah.
So.
Let's think about the thickness of that.
Yeah, so like I said, you're going to be chasing it, but then you got somebody you got to put the holes back where they belong. Like I said, this hole goes all the way down. This one intersects into that one. This one goes all the way to this one, and this one intersects into that one at a 90-degree angle. So, because you put your angles, you put welding on there, you can see all the different angles where they all go at. But somehow you got to retrace all these angles. So, that could be interesting. You pretty much need a good case, put it in the milling machine, light it all up, then put your case in, drill the hole, same spot. You know where the hole's going to be by the gasket. You just don't know what angle it's going to be.
Yeah.
So that's pretty much how you're going to have to do it. But anyway, this one's broken. So it might be easier to just get another case and then try to match to it. Might be an easier option. And it could be a shovel case too. Well, no, these are different up here. Now this side over here, we got to see if this is loose. This is not really repairable. Very difficult to fix that area, and it's pretty much. Okay, so I want to see. I gotta go. I can get something to press with over here. I need a block to push on right here. That's about the right size, but not too big. That's a little small. That'll work. Okay. Let's put trip hazard over here. Okay, so right now we can feel the height there.
Yeah.
So feel that? You feel it? It was highest up on this corner, a little bit lower on this here.
Yeah.
But it's pretty consistent. It's pretty even, but a little bit higher on this side. Okay, so this we're going to put onto over here, which is going to hold the aluminum, not the steel. You just kind of send it up with your fingers like that. Okay, this is going to push on the steel, not the aluminum. And what we're going to do is put some pressure on it and see what happens. Now, if you heat the case up to 350, 400 degrees, those inserts sometimes become loose in there. They start moving around. When they really are loose, you'll have 30 thou clearance in that race when you do that. It's really surprising how much they move. Okay, that's only 3 tons, not much. You heard that little squish?
Yeah.
Wasn't a pop, it was a squish noise. It's gone.
Yeah.
The lip's on the backside now.
Yeah.
So that's loose. You heard the squish as well inside the moving. So what happens is when the crank gets bad in there, it starts doing this kind of shit on the case race, and it breaks it free because it's just casted in.
Yeah.
And that becomes a problem. So yeah, so whenever I always feel a case right here to see now there's a lip there. See I'm catching it?
Yeah.
Okay, now we're going to do it the other side. We do the opposite now. Now we're on the aluminum. As best I can. Hope that's not tall enough. Need more height. I used to have a block laying around to do this a lot easier, but damn, how much higher is that thing? No, I'm on the damn right. I'm in the right spot. I'm not sure if I'm square or no, I can't. It's not a good reference over there for diameter where we're at, so we're just going to go with that and see if we're close. It doesn't fit very well either. We'll use this one here. Perfect. I don't think I'm really that close to the note, but yeah, we'll see. We're just going to do a... You'll also see that same thing on this, but this surface is a lot more worn.
Yeah.
You don't really feel it too much. Now let's see if we see anything move.
I heard it.
I don't really feel much difference there, but... See the oil residue?
Yeah.
This stuff was dry. It's not as much as it was. It is back on this side.
Yeah, it's definitely proud of the surface for sure.
There was more before.
Yeah.
But there's definitely oil in there, so you know it's gushing. We heard that gush noise too. Sometimes it'll just go like that. If they're really loose, I'll move just by doing that. But like I said, if you put that in the oven, even a couple hundred degrees, I bet you can feel that thing going up and down a little bit. So there's no real way of fixing this. They're really thin. These cases are actually really thin through here. There's not a lot of material.
Okay.
And it's hard to figure out how you can do it. Now Ultima has an insert that they put in their cases. I haven't tried using their insert in a Harley case yet. If they'd even sell me one. But if they would sell me one of their inserts, I would cut all the shit out, put that in there, and try to do it that way. And maybe we could save it. But I haven't tried actually doing that. I don't know if they'd sell me that piece or not. I don't know how their case is made relative to a Harley case. There's a lot of unknowns. So, but that might be a way of saving a case. I've tried pinning these things. I've tried stitching it. I've tried lots of different ways of doing it over the years. I've just put Loctite in them.
Like green or something.
Yeah, sleeve retainer. I actually would drill holes in here, 3 or 4 holes. You know, about 5 holes. So like a well. Heat the case all up, get all the oil burnt out of it. Because about 450, 500 degrees, all that stuff just boils out of there.
Yeah.
When it's all done clean, you clean it with brake clean and heat it up again and get all that shit burned out. Then I would put the crank in there, tighten the bearing up with no spacer in here so it's centered where you want it to be. And you put oil in that. You put the Loctite in there. First you got to put the Loctite in there first, but then you put it all together and heat the case up again a little bit because the Loctite will kind of move around a little bit. And then center it off with using the crank as a centering device to get this center to the crank. When they're really bad, they move all over the place. And anyway, you put the Loctite in here and get all that stuff in there. And I would use a sleeve retainer first, and then once I was done with that, then I'd go and put this capillary stuff in there. I'd do it from this side, I would do it from this side.
Yeah.
Whatever would soak in. It actually soaks in you. It's surprising. But I don't know how good that is. The Loctite's only good to about 300 degrees. If that case gets more than 300 degrees, the Loctite breaks free.
Yeah.
So. But none of the guys ever came back. So no matter which fix I've done, I've never had anybody come back saying it didn't work because they already knew the case was junk. So.
Yeah.
And you're not really going to know it's loose unless you're feeling more vibration in your motor, because that could be loose for a lot of years and you don't really know. But eventually what happens is these holes right here for these alternator screws,
Yeah.
they go between the aluminum. The steel insert has like fingers sticking out. It goes through the steel, it comes out the other side of the aluminum, so it's like a shear.
Okay.
It actually shears the screws off. But the biggest thing is if you constantly have an oil leak out here, like it's an open belt drive system, you keep putting crank seals in there, it's still leaking oil. 9 times out of 10 the case race is loose. It's just leaking oil right between the case half coming through. But like I said, I've had 3 motors where the screws kept getting sheared off. Yeah, they get loose all the time is one thing, but then they actually cut the screws in half. It was so bad, and those things were just fucking rattling. They had like 50,000 clearance in them.
Yeah, that's fucking crazy.
The bikes are still running, but the whole crank's just flopping around in there. It's vibrating like crazy. It's still running, but it's not very good. So, but basically, this motor right now is not rebuildable very easily. We'd have to see if we can save that case. The other case, probably replacing it might be a better option. But it's the same deal. You have to spend a ton of money on it. And right now, I don't know if an fxrp is warranted doing it. If it was a knucklehead or a panic case that sells, cases go for $3,000 up, yeah, spend $1,000, $1,500 a time, it might be worth it. But right now, you can buy a new case for $1,000, $1,500 aftermarket, not Harley, but how important is that VIN number to the case, to the bike?
Yeah.
Is that bike worth the extra time and effort? It's not like this case of cream puff. It's just destroy it everywhere you look at it. So, that can be cut out, put a lip in there. That lip can be welded up. There's a lot of stuff you can do to save these cases, but it's just the money invested for value return is not very high, unless you really want to have that case back together.
Yeah.
And I just don't see it in your bike. I think you just put a motor in it, a nice 107 Evo motor, bolt right in that bike. Be nice. Be cheaper too.
Yeah.
To fix this motor with today's pricing, $7,000-8,000 motor. Crank, everything's bad. The crank's bad.
Yeah.
Now we didn't measure those pistons. We're gonna measure them. We said they were standard. I didn't measure them yet, so I'll go measure them so we know. But You know, the cylinders can be bored out. The heads, you know, that one head's pretty bad. I'd get another head.
Yeah.
The time and effort, it's like this. The time and effort to fix that head, go buy another one.
Yeah.
It's not worth it.
Hmm.
There's too many of them out that are good. So, you know, but you start adding up all the stuff to fix a motor these days and the cost of those parts, it's cheaper to buy another motor by far. You know, new motor. But anyway, if you want to, you know, if you want to save it, we can save it. It just costs money. There you go.